So what we're going to look at today are some spectator ions. This is one of the more complicated parts of the acids and alkalis topic, but with enough practice it actually is quite easy. And from the name, spectator ions, we're going to be focusing on ions. So it's really important that whenever you're doing this topic that you're quite good at working out the ionic formula for different compounds. What we're going to focus on are, to start with, are the ions in acids and alkalis. Now we already know that acids produce H plus ions, and we know that alkalis produce OH minus ions. Now the reason they do that is because they are in solution. So we need to add on state symbols to these as well. AQ, and here AQ as well. That means they're in solution. But acids and alkalis produce other ions at the same time, and we're going to look at those. So firstly we're going to focus on the three main acids that you will see. And so we have hydrochloric, we have nitric acid, and we have sulfuric acid. Now we'll look at the chemical formula for each one of these. Now hydrochloric acid is what happens, is what forms whenever we react hydrogen with chlorine. Now hydrogen has a valency of 1, chlorine has a valency of 1, so when they react together, we get HCl. Nitric acid. Well, nitric acid is what happens whenever nitrate ions interact with hydrogen ions. And nitrate, if you look in the data booklet on page 8 at the top, you can see that nitrate has a valency of 1 and hydrogen has a valency of 1. So it's HNO3. Sulfuric acid is a bit different because sulfuric acid is a sulfate ion with hydrogen ions. Now sulfate has a valency of 2, hydrogen has a valency of 1, so we need 2 hydrogens for every 1 sulfate ion. Now when we dissolve these, we get ions. So when they dissolve, we get dissolved ions. And that means we're going to need to put on the state symbol AQ. Now in each case, we know we've got an H here, so we need an H plus AQ. We've got one H plus here, so we get H plus AQ. We've got H here, so again, we get H plus AQ. But with sulfuric acid, we have 2 H's, so we write a 2 here to show that we get 2 of them whenever it dissolves. Now with the other part, if we get a plus ion taken away from this, it means that we're also producing a Cl minus AQ, like that. With nitrate, we've got H plus, so that means the other one must be NO3 minus, and again, it's dissolved, so it's AQ. And finally, with this one, we have SO4, which is sulfate. Now, sulfate is a bit different, because sulfate is a 2 minus, not 1, 2 minus. AQ. And that's what happens. So we have the chemical formula here, and then we get dissolved ions. All acids produce the hydrogen ion, H+, and then depending on whatever acid it is, essentially take away the hydrogens, and for every hydrogen you take away, you put a -1. So HCl, we took away 1, so it becomes -1. From HNO3 here, we took away 1 hydrogen, so it's -1 here. For sulfuric acid, SO4, we took away 2, so it becomes 2-. For alkalis, if we turn this over, alkalis, for example, the main ones that you might go with are sodium hydroxide, potassium hydroxide, and ammonium hydroxide. And again, for each one of these, we have a formula. And then we're going to have dissolved ions. Now, sodium hydroxide, the chemical formula is NaOH. That's because hydroxide has a valency of 1, sodium has a valency of 1, so 1 each. Potassium hydroxide, potassium has a valency of 1, hydroxide has a valency of 1, so KOH. Ammonium, so ammonium you need to look at page 8 of the data booklet. You'll see that it is NH4, and it also has a valency of 1, and hydroxide has a valency of 1, so it's like that. Those are the formula. And you'll notice that in each one, you've got this OH ion. And that means in every single one of these, whenever it dissolves, we get the hydroxide ion being produced. But what's happening with the other side? We're taking away hydroxide, and hydroxide is negatively charged. Make sure I put that in on each one. That means what we're going to be left behind is something that's got a positive charge, and for every 1 hydroxide we take away, we're going to leave 1 positive charge behind. So for sodium, it's going to be Na+, and because it's dissolved, AQ. For potassium, we've taken away 1 hydroxide, so it's K plus AQ. And then for the final one, ammonium, again, exactly same thing. We take away 1 hydroxide, so we end up with NH4 plus AQ. So for every alkali, we're taking away 1 hydroxide. And we don't put a plus between them, we just have them floating side by side like that. Because they're still the same chemical, but they're just side by side. So for acids, in each one, for every hydrogen, we end up with 1 H+. And then what's left behind is the other thing, and it's got a negative charge. For every 1 hydrogen that's been taken away, you get 1 negative charge. So in the case of sulfuric acid, where you're taking away 2 hydrogens, it becomes -2. Now these ions are what are involved in the reactions of acids and alkalis. And what we mean by a spectator ion is an ion that is present in a reactant and is still present in the product. So we'll get a better explanation as we show an example. So what we will take is an example sodium hydroxide plus hydrochloric acid so that is an alkali, a metal hydroxide and a metal chloride and a hydrochloric acid and an acid. So they're going to produce a salt, which is sodium from here and chloride. And we're also going to get water. Now we write out the formula. Sodium hydroxide, NaOH. And that's going to be dissolved, so we need the AQ written in. Hydrochloric acid. And that's going to form NaCl. Again, use valency to work that out. And we'll leave that without a state symbol. And what? Water, H2O, liquid. Now what we need to do is we need to know if that's soluble or not. So we look up the data booklet. So this table, as we would, and sodium's here, chloride's here. It's very soluble. So that means it's going to have AQ. Now, the rule is anything AQ turn into ions. Anything that's AQ. If it is solid, liquid, or gas, keep as the full chemical. Okay? So if we look at this example, this is AQ, so we're going to turn it into ions. This is AQ, so we're going to turn this into ions. And this is AQ, so we're going to turn it into ions. Water is a liquid, so we keep it the same. So we're just going to indicate anything AQ. We're going to turn into ions. So now what we're going to do is we're going to rewrite out the equation, this equation, but what we're going to do is we're going to break it down into ions. And what I'm going to do is use different colours for each ion. So we're going to have, for the first chemical, sodium, and it's sodium plus from the last one, AQ. Now it might seem annoying, we have to write out the state symbol for everything. Then we have got hydroxide, AQ. Then we still put in our plus. Now we have hydrochloric acid, which we know acid produces H plus. And we then have chloride, Cl minus. Again, AQ. We have our arrow as normal. We've got sodium chloride. Now sodium, Na plus, AQ. We've got chlorine, which is chloride ion, AQ. And then we've got water. So we don't do anything to it because it was a solid, a liquid, or a gas. So we don't break it down. And then what we're going to do is we're going to see anything that doesn't have a match on the left and right hand side. So sodium, it's on the left hand side. Sodium's also on the right hand side. So we'll put a tick. Sodium's on both sides. We've got hydroxide here. There's no hydroxide over here, so we're going to just score that out. We've got a hydrogen ion, an H plus ion. Well, there's no hydrogen plus ion there, so we can score that one out. Now we've got chloride. Well, there's a chloride here. Tick and tick. And if we look over, this is an ions, so we can score that out immediately. Now, any ion that's on the left-hand side and the right-hand side, we call a spectator ion. So any ion that's on the left-hand side and the right-hand side is a spectator ion. So our spectator ions are Na plus and Cl minus. So that's how we do it. We'll do another example of that. Try a different chemical equation just to see the process happening again. What we'll do is we will do potassium hydroxide plus nitric acid going to, well, the name of the salt, we take the metal from here and we take the part from the acid to give the second part, so it's potassium nitrate plus water. Now we'll write out the chemical formulas. Potassium hydroxide, valency 1, so KOH. It's an alkali, so it's in solution. We then have nitric acid, HNO3. We just have to remember the acids, and it's soluble as well, it's AQ. And then potassium nitrate is KNO3 plus H2O. Now this one's a liquid, but again with the salt we need to know whether or not it's soluble or not. So as before, we look at the table, page 8. Potassium's here and nitrate is here, so where they meet it says VS, which is very soluble, and if it's soluble that means we get AQ. So now we need to do our ions. Now remember the rule, if it's in AQ we can turn it into ions. So that one we can, that one we can, and that one we can, but that's liquid, so we can't. So we'll start off, got K plus AQ. And beside that, we have got hydroxide, OH minus AQ. Then we've got our acid here, and we have H plus AQ, and here NO3 minus aqueous. Now we're going to here, we've got potassium, so let's use the same colour as we have on the other side, and potassium nitrate, NO3 minus AQ. And then remember, water, and what we do, like last time, if anything doesn't have a match, we're going to score it out. If something does have a match on the left hand side and the right hand side, then what we do is we'll keep it. So the first thing, we can automatically score out water because it's got no ions. Then let's start here. Potassium, okay, well let's look on the right hand side of the arrow. We've got potassium, so we will tick and we will tick. Hydroxide, right, we're on the left hand side. Let's go to the right hand side of the arrow here. There's nothing. Score it out. Hydrogen ion, on the left hand side. Let's look at the right hand side. No hydrogen ions, so we can score it out. And then we've got nitrate ion here, and on the right hand side we've got nitrate ion, so we can do that. And so our spectator ions are the ones that are on both sides. So that's going to be K plus and NO3 minus AQ. Now really the skill is learning how to break it down into ions. And if you can remember, for our standard, if you can remember those three acids and how they break down, and then those three alkalis and how they break down, you'll be fine. So that's 6 chemicals. If you know how to write them as ions, you'll be able to do this. Now, what I'm going to do is one final example. And this time I'm going to use a slightly different chemical. What I'm going to do is I'm going to use barium hydroxide. This is an odd one. Barium hydroxide. And I'm going to react it with sulfuric acid. Now the name of the chemical, the salt that's produced, is going to have barium, the metal from here, and then it's going to have sulfate from here. So barium plus water. So now we need to write out the chemical formula for each one. Now barium's a bit different because barium has a valency of 2, hydroxide has a valency of 1. So when we write the chemical formula out, it's going to be barium and then hydroxide 2. Now we add our sulfuric acid, H2SO4. And this is going to go to barium sulfate. Now barium has a valency of 2. Sulfate, if we look on page 8 of the periodic table, of the data booklet, I'm sorry, that has a valency of 2, so we have BaSO4, and we produce water, H2O. Now that's AQ, that's AQ, that's liquid. Before we look at this, we need to balance the equation. So we've got a sulfate here, that's fine. We've got 1 barium here, we've got 1 barium here. We've got 2 hydroxides and 2 hydrogens. So that's going to mean we need to form 2 waters because we've got 1, 2 hydrogens, 3, 4 hydrogens. So we need 1, 2, 3, 4. And then with the oxygens, we've got 1, 2. So we need 1, 2. Now what we do, just like before, we look at the data booklet and we're looking at barium sulfate. Now barium's here and sulfate is here. Now it's insoluble. So that means we have to write an S there. So let's really highlight that that's an S. Now remember, only AQ can turn into ions. Remember, only AQ. So let's put a star above the chemicals that we can turn into ions. Well, we've got AQ here, we've got AQ here, but no, can't do it with this one, and can't do it with that one because that's a liquid. That's a solid, so we can't. So if we start putting it into ions, what we have, so we've got barium, 2 plus AQ, plus 2 hydroxides. Oh, sorry, don't need a plus there. Plus 2 hydrogens, sorry, 2 hydrogens. Plus the sulfate, which is 2 minus, and it's going to BaSO4 solid plus H2O. Now what we'd normally do is we'd look at each side and we try and cancel out anything that's on both sides. But if you look here, we've got no ions on the right hand side at all. So nothing on this side is going to be on this side, because this is all ions, this is no ions. So in a situation like this, if the salt is insoluble, there are no spectator ions. And that is another important rule. So if the salt is insoluble, there will not be spectator ions at all. If the salt is soluble, if this is AQ, then we do exactly what we did before. We break everything up into its ions and look for whatever ions are the same on the left hand side and the right hand side and cancel everything else out. So that was spectator ions. It is a bit more complicated than some of the other parts of this course, but with a bit of practice, it should be no problem for you. Thanks for your attention.